Hello student, good morning. I am Dr. Sinha, Professor of Chemistry. Today I will continue from the last class. I was discussing this expressing concentration of solutions. How will you express concentration of solution? In that I have discussed mass percentage, W by W I have discussed. Second, volume percentage, V by V I have discussed. Third, mass by volume, W by V I have discussed. Also I have discussed parts per million. Now here only I want to tell you, just like parts per million, parts per billion is also there. Just in the place of million we will multiply by billion. Okay, but that is called actually PPB, parts per billion. If in million some things are not there or very less present in per million, then PPB is used. PPB, parts per billion. If the particles are very less in million also, if it is not present or very less, then PPB is used. Now I am going to discuss mole fraction. Mole fraction is very important, and concentration can be expressed in mole fraction also. To understand mole fraction, first you have to know about the mole. What is the mole? Then already I have discussed in details mole concept. In that I have discussed that molecular mass of the given substance is equal to mole. Molecular mass is equal to mole. Atomic mass is equal to also mole. Already I have discussed in details. Then here given substance, given mass of the substance, first you should convert into mole, correct? Then solute also should be in mole, solvent also should be in mole. This is the important condition, or you can say first condition to understand the mole fraction. Given substance must be converted into mole, correct? Or solvent, if it is given in mass, that also should be converted into mole. Now you can understand, because this concept will be used. Commonly used symbol for mole fraction is a small x, just like a small x, and subscript used on the right hand side of the x denote the compound. Okay, here first understand mole fraction. What is the mole fraction? Then mole fraction, I told you, it is represented by just a small x, like that symbol is there. Then mole fraction of a compound is equal to number of moles of the compound or component. Mole fraction of a component, here you are talking about the two component system, means solute and solvent, two component. Then here mole fraction of a component is equal to number of moles of the component which you are considering divided by total number of moles of all the components. Suppose first you understand two component. Then just like a solid plus a solvent, that is equal to solution, then solute. Suppose you want to know mole fraction of solute, then how many solute is dissolved, how many moles of solute is dissolved in water. Okay, that you have to calculate. And how many solvent molecules are there, moles, how many solvent moles are present, means how many solute is dissolved in how many solvent. First to add both, that will be total, means solute plus solvent, number of moles of solute plus number of moles of solute plus number of moles of solvent, that is called total number of moles of the components. Then suppose you want to know mole concept of solute. Out of 2, you want to know mole concept of solute. Then how will calculate? Then mole concept of number of moles of the solute divided by total number of moles of all the components. Here only solute plus solvent. Okay, then this is actually mole fraction of solute. Similarly, if you want to know mole fraction of solvent, then number of moles of solvent present in solution divided by total number of moles of all the components, means solvent plus solute. Means in case of solute divided by total, in case of solvent number of moles of solvent divided by total number of moles of solvent plus total number of moles of solute. Okay, that you add both, that is called total number of moles of solute and solvent. Correct? Then this is, I told you about when it is a 2 component, only 2 are mixed, solute, one solute, one solvent. But now it is not necessary that in solution only you can say one solute is present. That is also not necessary. Maybe more also, 2, 3 may be there. Then in that case, suppose 3 are there. So component 1, component 2, component 3, a component 4th is a solvent. Okay, that you forget. Then if you want to know component 1, mole fraction of component 1, then that number of moles of first component divided by total number of moles of all components, means that is the component first, component second, component third plus solvent, all you add it. Correct? Like that way, if you want to know this mole fraction of component 2, then same way number of moles of component 2 divided by total means component 1 plus component 2 plus component 3 plus component of plus solvent, number of moles of solvent, total. Like that way, third also same way, component third you want to know, then mole fraction of component third means number of moles of component third divided by total, means component 1 plus component 2 plus component 3 plus solvent, what are their molecules added. Correct? Then that is called mole fraction. Here you have to not multiply by 100 because it is only fraction, not the percentage. Percentage I discussed, that is in 3 cases only. That is the mass percentage there, volume percentage, and mass by volume, all are in percentage. Okay, parts per million, you have multiplied by 10 to the power 6. In case of ppb, parts per billion you have to multiply. Now mole fraction, no, you have to not multiply with 100 and is that, only mole fraction. And here again you want to know, this you should know that out of 2, if 1 you are knowing, mole fraction of 1 is knowing, then from 1 you can actually mole fraction of solute plus mole fraction of solvent is equal to 1. Okay, mole fraction of solute plus mole fraction of solvent is equal to 1. Hence, if you are knowing any one mole fraction, then just to deduct from the 1 minus mole fraction of solute is equal to mole fraction of solvent. Correct? This I have told you, that main concept I have told about the mole fraction. Now I am going little more. Okay, I will discuss little more. Then here number of moles, it is represented by number n, capital N. You can a small n you can tell, a small n, that is the number, small n. And this suppose 2 components are there, A and B. So solute, suppose it is A and solvent is B, then Na, a small n, and down you write capital A, means that is the, you can say, solute. Na, number of moles of A, divided by number of moles of A plus number of moles of B. A small n, capital B, B is for solvent, you can understand. Then Na, mole fraction, that is the X. XA means mole fraction of A, small x. It is represented by a small x, XA. Then it means mole fraction of A you are going to calculate. Then XA is equal to Na divided by Na plus Nb, that is for solvent. Nb, number of moles of solvent. Then this is for mole fraction of A, like for solute. Like that way, for solvent Nb. Then upside Nb, now you can write. First time Na upside and down total. Here now for the B, Nb you write what you are considering, that you write upside and down total. Then Nb divided by Na plus Nb, that is the mole fraction of B, that is the Xb. Xb is equal to Na divided by Na plus Nb. Nb small n, capital B you can write. Then this is actually mole fraction. And similarly, if there are more than 2 component, 3 and 4, then what I discussed, same way for any, suppose many components are present in a solvent, 1, 2, 3 like that, 1, 2, 3, 4, 5 components are there, like that way. Then you can write x1 is equal to n1 divided by total means n1 plus n2 plus n3 dot plus last ni you can tell. Okay, you don't know how many components are there, ni you can write. Then for n1, then you can write like this, n1 divided by summation sign ni you can write, because suppose I particles are there, I components are there, then total, summation means total. Then n1 or not one, any component, ni you can tell, ni you don't know which component. Then ni is equal to xi is equal to, xi means mole fraction of I, that is equal to Ni divided by N1 plus N2 plus N3 plus N4 dot 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 plus Ni. Then finally you will write Ni divided by summation of Ni. Okay. And already I told you, if you will add all mole fraction, means mole fraction of component 1 plus mole fraction of component 2, means x1 plus x2 plus x3 plus x4, all mole fraction you add, that is equal to 1. That is equal to 1. Okay. Now here again I want to tell you important things. Here you are talking about mole fraction, but in generally in question they will give mass, that also I have already discussed. Again I am repeating that they will give mass of solute, mass of solvent. Then your first what you do to calculate mole, then already I told you that mass divided by molecular mass. Mass divided by molecular mass is equal to mole. Given mass divided by molecular mass of that substance, that is equal to mole. Then you convert it in the mole first. Correct? These things you have to remember. Now again I am telling you, mole fraction unit is very useful. Mole fraction unit is very useful in relating some physical properties of solution, as for example vapor pressure with a concentration of the solution. That time this is used, mole fraction term is used, unit is used, and quite useful, also useful in describing the calculation involving gas mixture. That time also fraction is this mole fraction term is used. Okay. Now next term I am going to discuss that is molarity. Okay. Molarity, RITY, and the end RITY, molarity. Another term is molality, that is LITY. The first you understand molarity, RITY, don't forget, don't confuse with molality. Molarity, that is represented by capital M, and molality, that is represented by a small m. Okay, and minor changes there. It is very easy to understand. Number of moles present per liter of given solution. Number of moles per liter of the solution, that is called molarity. Number of moles is important. Per liter, 1000 ml. You have to finally convert into 1 liter, that is the 1000 ml. The number of moles per liter, that is called molarity, capital M. Okay, in a simple way you can write moles of solute, number of moles of solute, okay, divided by volume of solution in liter. Volume, moles of solute divided by volume of solution in liter. That's enough. That is called molarity. Correct? It is in liter. And what about the molality? LITY molality, I will tell you, just to wait. One example I will tell you about molarity, then I will come to that. Then molarity you have understood. number of moles of solute present per liter of the solution. Per liter of the solution. Then example I am giving you. For example, 0.25 mole per liter. If you can say molarity is, suppose example 0.25 mole per liter. It means what? 0.25 mole. That you can write 0.25 m, capital M. That 0.25 mole per liter, capital L, 1 minus 1 you can write, per liter. Then that is represented by 0.25 m. 0.25 m, capital M, molarity. 0.25 m solution. Now just suppose this 0.25 mole per liter, that is a 0.25 m solution of NaOH. NaOH is there. Okay, 0.25 m NaOH. What does it means? It means that 0.25 ml of mole of NaOH has been dissolved in 1 liter. 1 liter or cubic decimeter, 10 to the power minus 3. 10 to the power minus 3. Correct? That is called decimeter. Both are equal, liter and cubic decimeter. Cubic decimeter, both are equal. Then 0.25 mole. 0.25 mole is present. 0.25 mole of NaOH, sodium hydroxide, is present in 1 liter. That means then 0.25 mole means 1/4 mole. Then now you know that molecular mass is equal to 1 mole. Molecular mass is equal to 1 mole means here NaOH is molecular mass is 40. You can calculate very easily NaOH. Add all atomic mass. Na 23, O 16, H 1. 23 plus 16 plus 1, 40. Then 40 gram means 1 mole. Then 10 gram means 0.25. Then if 10 gram you will dissolve in 1 liter, 10 gram you will dissolve in 1 liter. Total volume should be 1 liter including 10 gram. Correct? First you take around 500, 600, 700, whatever, less than 1000 ml you take water. In that 10 gram you add and dissolve it. Total volume should be 1 liter, exact 1 liter. Correct? In that 10 gram is also you have added. Always you make solution like that only. Then now this solution will be called 0.25 m. Like that way, if suppose this 40 gram you have added, 40 gram NaOH you have added in 1 liter, means water you have taken 600, 700, below 1 liter, actually roughly you take 600, 700, but less than 1 liter. Add 40 gram. Slowly and slowly you dissolve it. Add 40 gram and then when it will dissolve, and then add water and make 1 liter. Make 1 liter. Then 40 gram, including 40 gram water should be 1 liter. Correct? Then 40 gram is present. Then 40 gram means 1 m. 1 m. Okay? 1 mole. Then that will be called 1 m NaOH. If 20 gram you will add then m by 2. That is called m by 2 NaOH. M. This I have discussed. Okay. Now you come to the molality. Same concept. What I have told you, same concept. Here number of moles present per kg of the solution. kilogram, 1000 gram per kg of the solution. That is the only difference. Here it was 1 liter, here is 1 kg. That's enough. Number of moles present per kg of solution. That is called molality, a small m. Okay. Then molality, that is denoted by a small m, is defined as the number of moles of the solute per kilogram kg of the solvent, and is expressed as molality is equal to moles of solute divided by mass of solvent in kg. Mass of solvent, not solution. Here one more you can say difference is there. In molarity, solution term you have used divided by volume of solution in liter, volume of solution in liter. Okay, here you are dividing by mass of solvent, not solution, solvent in kg. Many students will get confused. They will also consider as a solution. No, this you have to consider per kg of solvent. Okay. Now one example I am telling you. 1 mole per kg. 1 mole per kg means what? You can write 1 small m. 1 small m solution. Now see, this is you are considering KCl solution, potassium chloride. 1 m, small m, 1 or 1.00 m also you can tell. 1.00 m means 1 m solution of KCl, means that 1 mole of KCl means how many grams? 1 mole of KCl means how many grams? How many grams of KCl? Then you should remember some atomic weight for some common atoms. You should remember atomic weight. Here I want to tell you, now here all means now I have started physical chemistry, solid state finished. Then full physical chemistry will be, you can say, numericals based, concept based, expression will be there. Okay. Here you will find in physical chemistry all formula derivation will be there. Concept first you should understand, second derive the formula, third use the formula, means numericals you have to use, in numericals you have to solve. Okay. Then to solve the numericals you will use always molecular weight or atomic weight, because to calculate molecular weight atomic weight is required, because atomic weight you will add, then molecular weight you will get. Then this is very very important to remember some atomic weight of some common, at least common elements. If it is a somewhat uncommon, then in examination they will give some value, but for common they will not give. You have to remember atomic mass. Then here KCl, then K means 39, Cl means 35.5, then KCl, add both 39 plus 35.5, then how will you get? Add it, you will get 74.5, 39 plus 35.5, 1 you add, it become 40, then now 34.5, then 74.5, then more this 74.5 gram KCl means 1 mole. Okay. Then now this 1 m small m, 1 m KCl solution means 1 mole, that is the 74.5 gram of KCl, is dissolved in 1 kg of water. 1 kg of water. Okay, remember this. Here again I want you little more that each method what I have discussed, each method of expressing concentration of the solution has its own merit and demerit. Mass percentage, ppm, mole fraction and molality, this again I am telling you, mass percentage, ppm, mole fraction and molality, means these four are independent of temperature. Question is asked, theoretical question. Mass percentage is independent of temperature. Okay, ppm is also independent of temperature. Mole fraction also independent of temperature. Molality, not reti, molality, what I discussed now in the last, molality are independent of temperature, does not depend on temperature. Why? This is because volume depends on here again I am telling you, mass percentage, ppm, mole fraction and molality, these four are independent of temperature, does not depend on temperature. Whereas molarity, RITY, molarity is a function of temperature, means molarity depends on temperature. Why? This is because volume depends on temperature and mass does not. Then molality you have per kg, that is the mass, and solute is also in mass. Mass percentage all are depending on mass. ppm also is a particle. Then they are independent of temperature. 4 are independent of temperature. But molarity, because that is dependent on volume. Okay, wherever volume will be there, that will be temperature dependent. Question is asked. Okay, now I am going to discuss some numericals. Numericals is very, very important. Physical chemistry is not possible without numericals. Keep in mind. And physical chemistry, if you will solve can say numericals or problems or theory or numericals, if you will solve correctly, then 99% possibility is there you will qualify the examination, you will complete the examination. 99% I am telling you. Correct? Because others are not numericals based and concept based. Here fully concept based. Fully. Hence, if you will solve physical chemistry can say questions with numericals, theory plus numericals, then your possibilities will multiply many times to complete the examination, because it is based on concept and more numericals. Organic chemistry, inorganic chemistry, that is somewhat you can memorize. Organic chemistry again, maybe somewhere little numericals, but empirical formula, their numericals are there. Organic chemistry. Okay. But physical chemistry you can't imagine. problems without question without numericals. No. You have to solve. Mentally you should be prepared to solve the numericals. Sometimes only numericals will give. Only numericals. Only 1, 2 question, 3 question, theoretical they can give. Hence, you have to mentally prepared. Physical chemistry means mentally prepared for numericals only. And concept you have to remember. Concept is very, very important, because 100% they will not give same type of question. You have to think. Concept will be the same. Concept will be the same. Same concept you will use to solve the numericals. But question will be not the same. It will not come from the books. Okay, you may, particularly in IIT or medical, you will not find that means I am not talking about, I am talking about the advanced. It will not tell you. Even in UPSC concept, if you are knowing that can be solved, they will also not ask that you will find. Sometimes you can find, but in 70% cases you will not find. You have to think and you have to solve, and then you can answer. You have to apply the mind. And Csir-Net is a fully, you can say, concept based. Concept based, you will not find anything matching with books. Okay. Hence, concept is very, very important. You should try to understand the concept. Then now I am going to discuss some numericals based on this concentration. I have discussed expression, how you can express the concentration term on that basis. Simple meaning of concentration, you remember always mole per liter. Mole per liter, that is a common way. Other things already I have discussed. Concentration is equal to mole per liter, that you keep in mind. And mole is equal to mass divided by molecular mass. Then if you will remember the formula or concept, easily you can solve the numericals. Okay. And now I am just some numericals I am going to discuss. First question I am telling you, I will read the question, then I will solve the numericals. Okay. If tell you always you keep pen or pencil and paper with you, correct? It will help you. You can note down important things, because sometimes you may not find in the books also. In that time it will be helpful. Some concept will be helpful. New type of new concept. So many things you will find in books. So many things you will not find in ordinary books. Okay. Now question I am telling you. Calculate the mole fraction. Calculate the mole fraction of ethylene glycol. Ethylene glycol. That is actually, it is ethylene glycol is a dihydric alcohol. 2 OH group will be there. Okay. Then calculate the mole fraction of ethylene glycol C2H6O2 in a solution containing 20% of C2H6O2 by mass. By mass. Again I am reading. Calculate the mole fraction of ethylene glycol C6H2O2 in a solution containing 20% of C2H6O2 by mass. Okay. Here again one more important thing I am telling you that you will find only in higher classes, means BSc, not in your 11th, 12th. Then that concept sometimes is used here. It is not in your classes. Then what is that things? Here in mole fraction, you are writing total number of moles. Then mole calculation already told you that molecular mass, mass divided by molecular mass divided by molecular mass. Then here for mass small M term you can use. Just a theoretical concept I am telling you before solving these numericals. Because in tough numericals this concept will be used. Then here for mass small m, for mass of the substance, a small m you can use the term, and for the molecular mass capital M you can use, or here you just to understand n, because both will be m you will get confused. Then a small m divided by n you here you consider as a, or m only, no problem, just you have to differentiate only m, capital M as a molecular mass, then m divided by capital M, correct? And now for solute, this is for solute, and for solvent you can consider again these things, n you can consider for solvent, n, small n divided by capital N. Molar means here small n is solvent, a solute, mass of solute, and capital N is for solvent, just to understand. Okay, after that you can follow any symbol, that is not a big thing. Then n, small n divided by capital N, this is the mole fraction of solvent. Just to differentiate solute and solvent you are using these two terms, m and n. Okay, m for solute, n for solvent. A small n divided by capital N, that is for solvent. A small m divided by capital M, that is for solvent. Then now for total you want to know the total, then you have to add both m divided by capital M plus n divided by capital N, that you have to add. Then you will do simplification, correct? Then this will be in the down. Upside, suppose you are calculating for mole fraction of solute, then a small m divided by this, m divided by capital M plus n divided by capital N, a small n divided by capital N. Then now what you have to do, because upside is the, you have to take upside, you have to take this mole, number of moles, then that number of moles also you will write m, a small m divided by capital M, upside also number of moles, because a small m is the mass divided by molecular mass. In both cases, if you are calculating for solute, then m, a small m divided by capital M, upside, and down total means m divided by capital M plus n, a small n divided by capital N, correct? Same way, if you are calculating for solvent, then a small n divided by capital N, a small n upside, a small n divided by capital N, after that down both m divided by capital M plus n divided by a small n. Any one you consider, suppose you are calculating for solute, then upside a small m divided by capital M is there, and down both are there. Then here what is important things, why I am telling all the things, here if you will solve this this expression you will solve, then what you have to here you have to do that if you can say in presence of, suppose solvent is in more quantity, in comparison to solute. Solvent is in more quantity, as for example 90 ml water, 95 ml water or 98 ml water, and 2 ml is solute. 2 gram you can tell, 90 ml or 98 gram, whatever is, that is water is 98 gram and 2 gram is solute. Then here what actually I wanted to tell you, that here because in comparison to the solvent, solute is very, very less, then you can neglect the moles of solute. In down only, not up. Up will be, you can't do anything. Up, it will be like that only. In down, you can neglect. Suppose M capital for solvent, for solute it is less. M, small m divided by capital M. That suppose it is coming 0.01 mole. As for example, 0.01 mole plus that water n up. For the water means solvent, small n divided by capital N, it is coming 98, around 98, suppose 98, 99 is coming. Then in that respect, in respect of water is 99 moles, this is rest is the, if 0.1 or 0.01 is the mole of solute, then rest things are solvent only, maybe 99 point somethings. Then in respect of solvent, solute you can neglect. Okay, solute you can, number of moles of solute can be neglected in comparison to number of moles of solvent. This actually I wanted to tell you. Then your this solution will be easy. What you are solving, that will be, solution will be easy, because down portion now for small things you will, if you will calculate exact, it will take more time and it will be complicated. Then generally in comparison to the solvent, solute is rejected only in down, not upside. Upside will be like that. Otherwise, what will you solve? All things will be simple, with the wastage, no use. Okay, this actually I wanted to tell you. Then whatever formula you will get, that will be easy. As for example, now a small m divided by capital M, it was upside, and down it was down. If you will neglect this solute, then you will find only, down you will find only n divided by capital N, divided by capital N. Then now it became easy, you can reverse it, then what you will get? You will get a small m divided by capital M, and down will go up, you know that that things, then capital N will go up and a small n will come down. Then this you got the formula. This you got the very, very important formula. M divided by capital M into capital N divided by a small n. Four things are there. Okay. Then mole fraction of solute, if you are considering, then you know that mole fraction of solute means for solute will be upside. Then for that relation, you got the relation, mole fraction is equal to, mole fraction of solute is equal to m, a small m divided by capital M into capital N divided by a small n. This is for solute. Like that way, for solvent also, you can calculate. Okay, then there are five terms are there, 4 terms, and one is for mole fraction, either for solute or for solvent. Total 5 terms. Then out of 5, if in 4 you are knowing, 5th you can calculate. Out of 5, 4 you are knowing, then 5th you can calculate by cross multiplication. Correct? By doing cross multiplication you can calculate 5th one. This actually I wanted to tell you. In case of both solute mole fraction also same concept will use, and solvent mole fraction again same concept we will use, because this time solvent we will write number of moles of solvent we will write upside, means n, small n divided by capital N will be upside, okay, and down will be again both. Then solute you can remember, solute you can neglect, okay. This actually I want to tell you, because in examination many questions will be asked on this concept only. Many students, though you are not knowing what I told now, then they will be complete solution they will do exact way, and it will take more time, and you will not able to solve the numericals, okay. Then now I have discussed this special things. This is actually in lower classes this concept is not given, maybe in some books, in competitive books maybe, but now I have told you, okay. Now I am solving the numericals, and before solving one time I am reading the question. Calculate the mole fraction of ethylene glycol. Formula is given C2H6O2 in a solution containing 20% of C2H6O2 by mass, means ethylene glycol they have given by mass, okay, 20% of ethylene glycol by mass. How will you solve? Here they have given formula, ethylene glycol formula is given C2H6O2, and it is a 20%. 20% of ethylene glycol means C2H6O2 by mass. Then you have to calculate mole fraction. Then now you are knowing all the things concept. First you should understand 20%. Then 20% means what? In a general way, 20% means 20 gram ethylene glycol is dissolved in 80 gram water. Total became 100 gram. Not like that 20 plus 100. No. Always I told you, including solute, it should be 100. It should be 1 liter, like that concept. Okay. Then 20 plus 80 gram. Correct? 20 gram ethylene glycol and 80 gram water. Correct? Solvent is 80 gram. Then now you have a bifurcated this 20% meaning you are understanding. Then 20% means 20 gram ethylene glycol, gram, and 80 gram water. 80 gram water. Both are mixed. And now say it became very easy, 20 gram ethylene glycol. Then this ethylene glycol convert into the mole first. First you convert to the mole. Then 20 divided by molecular mass of ethylene glycol. 20 divided by capital M, molecular mass. Then how will calculate the molecular mass? C2H6, C2H6O2. Easily you can calculate. Carbon you know, that is atomic mass is 12. Hydrogen is 1, oxygen is 16. Okay, I am telling you, just get it to the heart. Remember, don't wait for anything. You have to remember, you will have to. Otherwise, you will not able to solve any numericals. Okay, and you can't ask for all the thing for your, hey, don't see here and there. No, you remember. Okay. Then here I am telling you carbon is 12, hydrogen is 1, oxygen is 16. Then C6 means 12 into 6. Okay. Not C2H6O2, C2H6O2, then 12 into 2 plus H6, then 1 into 6 plus O2. 2 into 16. 2 into 16 means 12 into 2 plus 1 into 6 plus 16 into 2. Then if you will multiply all and will add, then you will get 62 gram. 62 gram means 62 gram is the molecular mass. 62 gram is the molecular mass. Then now capital M value are knowing, small m value are knowing, m by capital M means 20 divided by 62 you are knowing. Then you can, after solving, you will get 0.322 mole. 0.322 mole. Mass divided by molecular mass, that is the mole. Then now this ethylene glycol, you are knowing number of moles, that is a 0.322, 0.322 mole. Like that way for water you can calculate the moles, number of moles. Then 80 gram water is there, 80. Then now 80 gram water means how many moles? Then molecular mass of H2O, how much? H2O means 2 into 1 plus 16, that is 18. 18 gram is the capital M. Capital M is 18 gram molecular mass. Then 80 divided by 18, 80 divided by 18. Then how much easily you will get the value after simplifying. Okay, and one thing, always you try to calculate in mind. This is the best method for competitive examination, because calculator will be not allowed. Okay, then you have to think, you have to do calculation in mind. And here only what I am discussing, that is the very good for you people, that I am telling you also think in mind. If you utilize your mind will be sharp, very sharp. All things calculation do in mind. Here we are not telling you too much very big calculation, but what is possible you can do. Okay, you can do in mind only formula. You are knowing that you put some value and solve it. That idea you just make habit. Then you will not face problem in examination hall, because already you have made idea, you have done these things, you have done practice. Now 80, this number of moles of water means 80 divided by 18, 18. And again I am telling you, giving you hint, then this 18 is very close to 20. 18 is very close to 20. Then 80 divided by 20, you will get 4. Then 4 you got idea very quickly. Rough calculation you have done. But 18 is there. Then it means it will be little more than 4. Little more than 4. Then sometimes in examination they will give a rough option answer. They will give in such a way option, just like not exact. You will, by seeing you can understand. Okay, 4 is there, down 18 was there, little more than 4. You can get idea of answer, because differences will be, 4 option will have a major differences. Then you can get idea. This is one technique I told you. Just to make it in a round figure and then you solve it. Then you will get, try to get exact. Rough idea you will get. Then 80 divided by 18. 80 gram divided by 18 gram. You will get more than 4. Then exact is actually, I will solve, you will get 4.444 mole. 4.444 mole you will get. Then now you are knowing both number of moles of solute you are knowing, number of moles of water you are knowing. Then mole fraction of solute, very easily, number of moles of ethylene glycol divided by total, means moles of ethylene glycols plus moles of H2O. Okay. Then here what I have discussed, same concept is there. Now 0.322, that is the number of moles of solute, divided by again total, means 0.322 plus 4.444 mole. Okay. Then here you just to see, here it solute is 0.322 and water 4.44s are there. Then here you can't neglect, because 0.3 is there and that is a 4. Okay. And here if differences are more, solvent is very high, that time you can neglect. Here you can't neglect, because differences are not too much difference. Okay. 0.3 is there, here 4 is there, hence you can consider. Then now add it and divide it. You will get mole fraction of glycol, ethylene glycol, that is the solute, that you will get 0.068. Correct. This is the mole fraction of ethylene glycol. Okay. Now, but I am telling you for the rough idea, if mole fraction is very large in comparison to the solid, that time you can neglect, then that will get little rough, not too much, little rough. But here, because differences are not too much, hence you can consider. And like that way, solubility of these things. Similarly, you can calculate mole fraction of water. Then water is 4.444. Here divided by again 0.322 plus 4.444. Then after solving, you will get 0.932 mole fraction. Then see, for this thing, ethylene glycol, you got 0.068, but for these things, water, you got 0.932 mole fractions. Water is more. And also you can get, if suppose any one fraction you are knowing, any one, either solute or solvent, then you have to not calculate second one. Directly from 1 you deduct 1 minus solute, 1 minus mole fraction of solute. Then you will get the mole fraction of solvent. Okay, this is easy method. Any one you calculate, other from 1 you can calculate, because mole fraction of solute and mole fraction of solvent, if you will add, then that you will find 1. That you will find equal to 1. Just I am telling you that M divided by capital M. Correct? Again, that mole fraction, mole fraction suppose for solute, then M divided by M plus N, plus mole fraction of solvent, then N, small n divided by M plus N. Then N plus N you can take LCM, M plus N only, and upside again you will get M plus N. M plus N down up will cancel, you will get only 1. Correct? M divided by M plus N, again plus N divided by M plus N. After doing solution, after solving, what you will find? Upside M plus N, down also M plus N. Both will be cancelled. That is equal to 1. That's why mole fraction, if you are knowing, if it is a binary, only 2 are there, then easily you can calculate. Okay, from the 1 you calculate, you will minus solvent, then you will get solute. If you will do minus solute, then you will get solvent. Now I am other numericals I am just first question I will read, then I will solve. Now you can solve the question very easily because all concept I have told you. Now question is there, calculate the molarity, RITY, molarity, capital M. Okay, always when you are solving this molarity question, then a spelling you see. Okay, and whether it is symbol is M or a small m, that also be careful. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml of solution. 450 ml of solution. Then molarity solution is only required. And 5 gram NaOH is there. Then now 5 gram, then formula you know, mole divided by liter. Then 5 gram NaOH. Then quickly you convert 5 gram NaOH in mole. 5 divided by 40. NaOH is 40 molecular mass. Then 5 divided by 40. Then you will get 0.125 mole. 0.125 mole. That is the number of moles of NaOH. And it is dissolved in this 0.125 mole. Number of this mole is dissolved in 450. Then 0.125 divided by 450, correct, into 1000, upside 1000, because per liter you have to calculate, correct. Then you will get this thing, 0.125 divided by 450 and upside 1000 milliliter, because you have to convert per liter. It is dissolved in only 450. 0.125 is dissolved in 450. In 450, 0.125. Then in 1 and then in 1000. Then you will get, after solving, you will get molarity is equal to 0.278. 0.278 m, capital M you can write. That means 0.2 molarity is equal to 0.278 mole per liter. Okay, liter also you can write decimeter minus 3, dm minus 3 you can write. Okay, liter you can write decimeter in term of decimeter minus 3. Okay, then now you solved these numericals. This type of numericals will be asked in examination, or without this formula, even for advanced, you can't solve. Because this formula is important. Okay, and they will give a big question. They will make it a big question so that a student should get confused. And they should not solve. There in examination, they want to reject the student. Keep in mind. They want to reject the student. That's why a question they will give long question, so that those students who are not have concept, they will not touch the question. But those who are knowing, they will read and they will understand and will quickly solve. Now next numericals I am going to solve. That question I am reading. Calculate molality. It is based on molality. Calculate molality, LITY. Calculate molality of 2.5 gram of ethanoic acid. Means acetic acid, CH3COOH. Formula is given. Acetic acid, that is called ethanoic acid. Calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. Now it is not water, it is 75 gram benzene. You have to convert in kg, you know. 75 gram benzene. Both are in gram. Then 2.5 gram ethanoic acid. 2.5 gram. Formula they have given, CH3COOH. Then now you know this gram you have to convert into mole. First step, mole. Then 2.5 divided by capital M. Then capital M, how will you calculate? Then now easily you can calculate CH3COOH means 2 carbon is there. A formula wise you also keep this thing value. CH3 means 12 plus 3, again 12, and double O is there, then 2 into 16, again plus 1. Formula like that also you can write the add it. CH3 means 12 plus 3 into 1. After that again C is there, then plus 12. Again 2 oxygens are there, then 2 into 16 H, and then H is there, plus 1. Then you can calculate the molecular mass. It will come 60 gram. Then molecular mass is 60 gram per mole. Okay, 60 gram is the capital M value, 60 gram. Then now 2.5 gram divided by 60 gram. 2.5 gram divided by 60 gram, that is the, you can say, moles of ethanoic acid. Then what value will come? 2.5 divided by 60. Okay, then its exact value will come, if you will solve, 0.417 mole. 0.0 or 0.0417 mole. Then here I am telling you again, you can apply little technique. 2.5 is there. 2.5 divided 60. Then 2.5 either you consider 2 or you consider 3. Okay. Then quickly first you will get idea. Then suppose you are considering 3. 3 divided by 60. 3 divided by 60. Then 1 by 20 will get. 1 by 20. Then you can calculate that it will be around point this things it will be around 0.5. You will calculate, then you will get little idea, but exact then you have to simplify exactly. Then now you are knowing that this things 0.04 you will get. 2.5 divided by 60 means I told you rough calculation, then 1 by 20. If 3 will consider 2 point, you will consider 2.5 will consider as a 3 by 60. 3 by 60 means 1 by 20. Then 1 by 20 just to calculate in mind. Then you will get around 0.04 or something near what. Anyhow, I have told you everywhere it will not work, but sometimes it will work. Then 0.0417 mole, that is the this mole of 2.5 gram means 0.0417 mole of ethanoic acid. Then now benzene, 75 gram benzene also you have to calculate mole. Then 75, what is the capital M? 75 divided by M, capital M. Then benzene C6H6, then 12 into 6 plus 1 into 6. Then 72 plus 6, how much? 78. 70, no. This C6H6, then C6, 70, 22. 12 into 6, 72 plus 6, and then it will come 72 plus 6, 78. It will come these things, you add this all moles of benzene, 7 moles of benzene, that is benzene is C6H6, that is the benzene. Then 12 into 6, 72 plus 6, 78, okay. Then mass of benzene you can calculate. First actually here what you have to do, actually here is a gram, you have to not convert in mole, correct? Here you have to not convert in mole, only for this solute you have to convert in mole, okay. But water is in kg, water solvent in kg, hence you have to not convert into mole, no, not required. Then here 75 gram is there. Then direct you can write mole you have considered, ethanoic you have considered 0.0417, 0.0147 and divided by 75, upside 1000, because it is dissolved in 75 gram. 75 gram contains 0.417 mole. Then for 1, then for 1000. Then you will get 0.417 into 1000 divided by 75. You will get 0.556 mole per kg. Means 0.55 mole is present in 1 kg. Here keep in mind that it is per liter is in molality, is in kg, hence it should not convert in mole. Only upside you have to convert, means solute. Okay. Then now molarity of ethanoic acid is equal to 0.556 mole per kg. Then now I have discussed numericals, and next class I will discuss solubility. Okay, now I am stopping only here. Next class I will start solubility. Thank you.